In this video, we're going to be answering, this is going to be page 2. We'll go over questions 6, 7, as well as 8, 9, and 10 at the bottom. All right, so for questions 6 and 7 is going to be dealing with this piecewise function here. We're going to be asked to evaluate f of -6 plus f of 0 plus f of 10. And I don't want you graphing these because that's very time consuming. So we have to learn how to plug stuff in appropriately. So I want to evaluate f of -6. What I'm going to do is, well, let's do a little reteaching on this. If I'm looking at the number -6, that's going to fall between -5 and -8. -8 is going to be over here. -6, -7. Here's -5. And notice that -6 falls right in there. Okay, so if I look at this interval here, -6 is in there. Now, when I'm evaluating f of -6, I'm not plugging it into the inequality. I'm plugging it into the function part before the word for or if or the comma. So in that case here, f of -6 is going to be whatever your output is right there. Well, in that case, there's no x, so it's just -5. Now, if I'm going to f of 0, well, 0 doesn't fall in there. 0 is over here. 0 is going to be, here's -4, -3, -2, -1, and then 0, well, that's going to be between -5 and 3. If I keep going, 1, 2, 3, 0 is going to be right in there. So 0 is going to get substituted in for that function. Now, I do have to plug 0 in. So I can use a calculator or use some mental math. You can use a calculator if you'd like to, but when I'm plugging that in, f of 0 is going to be replacing that x with 0. So it's going to be parentheses 0 plus 1 raised to the second power. And if you're doing this without a calculator, you would simply say, well, 0 plus 1 is 1. And 1 squared is 1 times 1, which is 1. So f of 0 is 1. But then finally, if I want to evaluate f of 10, well, on this inequality, 10 happens to be greater than 5. So I'm going to substitute 10 in for x minus 7. So f of 10 is simply going to be 10 minus 7. Now, if I take away 7 from 10, I'm going to get 3. So f of 10 is equal to 3. And in this case, I just need to add them together. So -5 plus 1 plus 3. -5 plus 1 plus 3 is -5 plus 1, which is -4, plus 3 equals -1. So your final answer is going to be -1. Now, question 7 says, give an example of a value of x where f of x is undefined. So based off of our inequality statements, are there any numbers that we cannot plug in? Think about that for a minute. I'm going to pause it and show you on a graph too. This is what it's going to look like keyed into Desmos. You're welcome to key this in if you'd like. The question says, give an example of a value of x where f of x is undefined. Well, there's plenty of places, there's plenty of numbers that you can't plug in. Notice that anything below -8, zoom out a little bit, and you can see this graph just kind of stops at -8. So even -8 is undefined, or -9, -10, anything over on that side. Also, if you notice, there's a gap between 3 and 5, which means you can't there's nowhere to plug in 4. So there's plenty of numbers here. Anything less than -8 or less than or equal to -8, or the number -4, or even 5, because 5 is undefined as well. So we have a lot of options. And you can also see the inequalities. If you look at just the number line here for a minute, -8, -5, 3. I'm not going to worry about anything else, but if you look at the way the inequalities are met, this -8 is going to be an open circle. This -5 is going to be an open circle, but then between -5 and 3, those are both going to be closed from the middle inequality. And then anything after 5, so -8, -9, -10, those are going to be connected. -5 works, -3, 4, 5, lots of examples. So you could say, for example, 4, 5, -8, -9, -10, et cetera, et cetera. And it just says give an example, so one should suffice. So any of those would be good. All right, part 2, absolute values. For this one here, it's really helpful to just know your function rules. So the question says, describe all transformation that occurs from the absolute value function, y equals absolute value of x, based off of what you see over here. Now, if you don't remember, the parent function for absolute value is simply going to be this V shape. Okay, so that's going to be y equals the absolute value of x. Now, as far as the transformation go, think about what happened. Okay, it flipped over. We call that a reflection over the x-axis. So anytime it flips over, it's going to be a reflection over the x-axis. It also shifted 1, 2, 3 units to the left. Because if you look at this coordinate, that's 3 units from this way. So it's going to be left 3. And it also went up 1, 2, 3, 4 units. See that coordinate there is 4. So it's going to be up 4. And that should cover it because it's not skinnier or narrow or wider. So it's going to be reflection over the x-axis, left 3 and up 4. So that equation will look like this. Anytime it's a reflection over the x-axis, it's going to have a negative on the outside. So you have negative. Now, because it's not being stretched or compressed, you're not going to have a number here. That's just going to stay negative, okay? Over here inside, you'll have your x, and since it went left 3, that's actually going to be plus 3 inside. We'll graph that to verify. And then since it went up 4, that's also going to be plus 4. And so that will be your new function represented here. I'm going to pause the video and put it in Desmos so you can verify it. You should do the same. Here you can see the original graph, y equals the absolute value of x. If I put in my answer, it does seem to match what I see on my paper, -3, 4, and it's opening downward. So that should take care of question number 8 and 9. Let's move on to the next one. Question number 10, write a new function based on the absolute value parent function, f of x equals the absolute value of x that has undergone the following transformations. Vertically compressed. So a vertical compression might be something like y equals a number out here that is between 0 and 1. That's going to be vertically compressed. If it's vertically stretched, it'll be above 1. So vertically compressed could be something like 1/2 or 1/3 or 0.2. Any of those would be considered a number that could vertically compress it. Shifted up means you want to add a number on the outside of it to the right. So that's going to be up. It'd be down if it were minus a number. And then reflected over the x-axis would have a negative. Just ignoring the a, just said there'd be a negative, whether there was a number there or not, it'd be reflected over the x-axis. Shifted right is going to be a minus inside. So a minus a number is going to be right. So there's infinite options here. So I'll give you an example. Y equals negative. We'll just say 1/2, absolute value. And if I want to go x, if I want to go that right, I'm going to say x minus, I don't know, we'll say 4. And then shift it up. Maybe we'll do plus 3. Okay, so that'll be reflected, compressed, right 4, and up 3. So that is my example, but there are an unlimited amount of examples that you could put in this question and still get it correct. All right, that takes care of page 2. Next video, we'll go over page 3.